Hello everyone. Today we are going to talk about descriptive measures. First of all, let's think about what descriptive measures are. So normally we use descriptive measures to describe a data set. For example, if you have a lot of data, then it's hard for you to make a decision or have some idea about the data set. Descriptive measures help us to get a better understanding about the dataset that we have with us. So let's move on. First, we are going to talk about measures of center. Measures of center or measures of central tendency indicates the center of the dataset. And there are three main measures of centers that we are going to focus today. Those are mean, median, and mode. First, let's look at the mean. Mean is the sum of the observations divided by the number of observations. As an example, we can look at this data set where weekly wages of 13 employees are given. So the data set is as follows: 300, 300, 300, and so on until 1050. So if you want to find the mean of this data set, or the mean wage or average wage of this data set, it can be calculated as follows. So mean is defined as the sum of all observations divided by the number of observations. So let's sum all the observations as indicated here in the numerator and divide by the total number of observations, which is 13. And the answer is 483.85, which is our mean for this sample. Next, we're going to talk about the median. Median is nothing but the midpoint of a data set once the data set is ordered. So we can define midpoint as median as the midpoint of ordered observations. So there are two. We can find the median in two simple steps. The first step is always to arrange the dataset in increasing order. Second step is, if the number of observations is odd, then the median is the observation exactly in the middle of the ordered list. If the number of observations is even, then the median is the mean of the two middle observations in the ordered list. Because when you have an odd number of observations, you can properly find a value in the middle. But if the number of observations is even, then there's no actual value in the middle. Instead, actually there are two values that are in the middle of the dataset. So in that case, median is defined as the average of those two values or those two observations in the dataset. So let's look at this with an example, right? So, and also we can say, if we let n denote the number of observations, then the median is at position n plus 1 divided by 2 in the ordered list. Okay. Now let's move on to the example. Example 1. Find the median of the following data set. So you have 4, 7, 19, 9, 20, and 11. So the first question that you should ask from yourself is, are these data in order? The answer is no. Are these numbers in order? No. So first you should order them. So the first step is to write them in ascending order. So you have 2, 4, 7, 9, 11, 19, and 20. Right. Now, step 2 is to find the median. Now, in step 2, the first thing that you need to note is the number of data points in this data set. So here you can see that there's 1, 2, 3, 4, 5, 6, 7 data points altogether. So the number of data points is 7 and it is an odd number. So we should be able to find the median exactly. So median should be at the position n plus 1 divided by 2, which is 7, as n becomes 7 right now. So 7 plus 1 divided by 2. So the answer is 4th position. Remember that this is not the median, this is the position of the median. Okay, so please keep that in mind. So to find the median, you have to go to the 4th data point of your data set, which is 9. So in this particular example, median is 9, which is the value at the 4th position. Let's move on to another simple example. In this example, we have 30, 32, 25, 27, 24, and 25 as our data set. And you can clearly see that it is not in order. So the first step is to write them in ascending order. So you would have 24, 25, 25, 27, 30, and 32. Step 2 is to count the number of observations first. So we have 6 observations here. So our n is 6, which is an even number. In other words, here we cannot find a proper mid value as before. In this case, what we do is we can see that there are 2 observations that are in the middle. So we take the average of those 2 observations as our mean. We cannot identify a proper value in the middle as in previous example where n is odd. Okay. So median should be, if we use the equation to find the position of the median, we would end up in 6 plus 1 divided by 2, which is 3.5th position. Actually, this position does not exist actually. There's no 3.5th position. So what this means is we should take the 3rd and 4th observations as the values in the middle. So there are 2 values which are in the middle of the data set. Therefore, we take the average of those 2 numbers as the median. So in this case, median is equal to value in the 3rd position plus value in the 4th position divided by 2. The value in 3rd position is 25 and the value in 4th position is 27. You add those 2 numbers and divide by 2, you'll get 26 as your median. Finally, we're going to talk about the mode. Data value that occurs with the greatest frequency is defined as the mode of a data set. Let's look at an example. Find the mode of the following data set. You have 24, 25, 25, 27, 30, and 32. And you can clearly see that 25, the number 25, is repeated twice and every other number is only repeated once. So the number that has the highest or the greatest frequency is 25. So 25 becomes the mode in this case. So the mode is 25. Example 2. So you have your data set as 23, 24, 25, 27, 30, and 32. What we can see here is that none of the numbers has occurred more than once. So in this case, we cannot find a mode for this data set. Right, so we talked about the mean, median, and mode, which are the most important topics under measures of central tendency. Now let's compare the things that we learned to get some better idea. Comparison of mean and median. Let's look at properties of mean first. It is the balance point of a data set. Mean is highly influenced by outliers or extreme observations. For a skewed distribution, mean is pulled in the direction of the longer tail relative to the median. Here are the properties of median. It is the midpoint of the dataset. That is how it is defined. Median is not influenced by outliers. So the reason for this is, if you look at the mean, when you calculate the mean, we consider all the observations that are present in our data set. Now, if we have outliers, which means if we have extremely high values or extremely low values than usual values, then those values can affect the mean. But when we are finding the median, we're going to order the data set, and if we have outliers, they will be in either leftmost corners or rightmost corners. So when we are finding the median, to the value that is in the middle, outliers will not have any influence. Finally, let's look at the sample mean. For variable x, the mean of observations for a sample is called the sample mean and usually denoted by x bar. Symbolically, we can denote x bar as the summation of xi divided by n, which is the sample size. Let's look at an example. Blood pressures of 5 children of diabetic mothers are as follows: 81.6, 84.1, 87.6, 82.8, and 82. Let xi denote the variable arterial blood pressure of the ith mother. Find the sample mean x bar. So x bar is equal to the summation of xi divided by n. Here n is 5. So we have the summation on the numerator and divided by 5, we get 418.1 divided by 5, which is 83.62, which is our sample mean. And that's all we are going to talk about today under this section, and see you with another section. Bye.